All right, so we just looked at the exam solutions. People who aren't in class today, hopefully they'll stop by and pick up their test. You've just turned in a homework assignment as well, and I'll post another one immediately after class. Homework 12 will be due a week from today, and then 2 weeks from today you'll have the project due. So the next couple of weeks will be busy, but then things slow down and calm down a little bit as we've got the Thanksgiving holiday at the end of the month. Today we're moving on to chapter 15 in the textbook, where we'll talk about some techniques used for cost estimation. And before we start talking about the unit method and the cost index, does anybody have any announcement or schedule related questions? Cost estimates are important because they help us to decide which projects should be accepted. You know, so far in the semester, I've just always told you how much profit a project is going to make, how much it's going to cost, and we've taken it for granted that that information is accurate, but it actually takes quite a lot of effort and precision to generate good quality cost estimates, and it's important. A company which bids on a project on the basis of bad data or bad techniques in cost estimation could end up going bankrupt because of it. So the stakes are very high. Cost estimates will help us to understand like which alternative to select. So in the case of a government agency which is doing a cost estimation, they may try to find out, you know, whether to make improvements to the fire station or to the hospital. Or if we are trying to determine which features to include in a project and there's limited funds available, we may not be able to afford both a wheelchair lift and also an automatic external defibrillator. Like if you've ever seen those in the airport or in public buildings, sometimes they're the ones where if somebody's having a heart attack, you could attach it to them and it kind of automatically senses when and how much to shock them. And we don't have money for every feature, and so we have to understand both how much an item will cost and then also what kind of revenue yield it might have. Neither of these would generate revenue, but they might help to satisfy compliance regulations that are in place for accommodating disabled people and being prepared for emergencies. So some of the rules that have been developed with cost estimation is that when we generate estimates of how much things are going to cost, it should be based on data that's representative of the current situation. So for example, if you're building a wastewater treatment plant in Alaska, it maybe would not be a good practice to use cost data which was generated in Arizona, because the two different climates have a very huge impact on the performance of wastewater treatment processes. It could be that the isolated location of Alaska also drives up transportation costs and labor costs. And so you have to put some thought into when you're trying to project how much something might cost, whether the past data you're basing it on truly is representative of the current situation. It's also important that you don't try to reinvent the wheel and come up with your own formulas or your own method for cost estimation, because there are accepted statistical methods and cost estimation techniques which have been used for a long time and have proven reliable. And so you should be aware of and use those techniques and accepted methods for generating cost estimates. And then the last component of it is the fact that sometimes when people are putting together cost estimations, there can be biases or temptations to be unethical when engineers in particular are specifying the materials that should be used in a project, and they have a friendship or maybe a previous personal relationship with the suppliers of materials or the subcontractors that are offering services. And so you have to avoid bias, you have to avoid the unethical entanglements that would maybe throw off cost estimates and lead you towards choosing a supplier that isn't the best value for your client. So one of the techniques that can be used for cost estimation is the unit method, which we'll be talking about today. And I use the unit method in a research project where we were looking at how water flowing through streams in West Virginia was eroding the rock that bridge foundations are built on. There's this problem at some bridges in West Virginia that the rock underneath a bridge pier begins to crumble and be washed downstream, and then obviously the bridge itself is a little bit unstable if the rock, which you can see here, starts to be scoured away downstream. So what we did for that project was we drilled in through the pavement and down, got samples of the rock, and we wanted to test the quality of the rock and like how resistant it was to breaking up. So we used a drilling subcontractor for that, and the cost estimate that they put together included some money for the maintenance and protection of traffic. You can see that they've got traffic cones there. I don't recall whether they had somebody holding up stop signs to, you know, kind of manage the flow over the bridges when one of the lanes was down. But there was also an initiation cost, or a mobilization as they call it, where, you know, just getting all of the equipment together and on site, there's a certain lump sum that you have to pay for that. We had to pay for a certain amount of money for each person that was on site. We had to pay for somebody to record the core samples that were brought up and to catalog and wrap in paraffin film so that the rock didn't get dried out before it was tested. So the costs that we had to pay were based on, for example, the number of feet that were drilled, the number of days that the crew was on site, the number of locations that the mobilization had to be applied to. And so the cost estimate we got from them wasn't just a lump sum out, you know, like a number out of thin air, but it was based on the amount of work and kind of a breakdown of the components of the work. And so a similar thing, if you're getting a cost estimate from somebody to put in a concrete driveway at your house, you could maybe feel a little bit better about the estimate you received if they are saying what is the total square feet of the surface that they're going to be covering with concrete, and like the total length of the formwork that they're putting up, and the number of days that they expect to be on site, and the number of concrete trucks that are going to be there. And like if you see some resolution to the estimate, you can have a stronger sense of security that it's a reasonable estimate than if it's just a bottom line lump sum where you don't know if you're being overcharged or if there's any relationship between the expenses that they'll face and what you're going to pay. We've talked about different components of costs before, and remember that direct costs are those which can be allocated to a specific task or a work activity. So if you could answer the question, how much, for example, concrete does it take to make a paved driveway, that's an example of a direct cost, is the amount of materials that are being used for something. So that can be applied to labor salaries, applied to production expenses, but indirect costs are things where you couldn't necessarily answer the question of how much of that does it take to make a certain thing. And so if it can't be allocated to a task, then we'll usually try to recover indirect costs by just using a percentage or a flat rate or some kind of a factor. So if you're using computer systems to manage an industrial process or accounting services or the rent of a building, those are all indirect costs which you have to cover those costs, but it's not as easy to say how much of it is being used for a certain output of what's being produced. Has anybody eaten at a restaurant called Sweet Green? And it looks delicious. I'm hungry right now because it's lunchtime. I was just before class looking at some of these salads. I set it to Indianapolis. I don't know if the costs are different in like New York City than Indianapolis. There isn't one around here, but I think the idea is they're trying to be a little bit more healthy than just getting a burger and fries and a milkshake. You know, they've got really good quality ingredients, a lot of variety, but it's kind of pricey. $15 seems to be the starting point. These are the protein plates. I think the salads are similarly pretty expensive. You know, in Indy, $13, $14. Depending on what you get, if you go for the steak, it's always a little more, $15. And so the reason why I wanted to show you that is I saw some interesting data recently which was talking about like why $15 for a salad. This is a breakdown of how much money they're actually losing each time they sell a $15 salad. And you would have thought maybe that they'd be making money by charging $15 for a salad. But unfortunately, for them, they're not covering their costs. So if they sell one salad for $15, it looks like the cost of operating, generating that salad is $17.56. And breaking that down into some of its individual components, there are the operating costs with the actual location. So we were looking at like a $15 salad in Indianapolis. So of that $15, $12.29 is associated with the operating costs of the individual location, whereas $5.27 would be the operating costs at the national level. So it'd be like the corporate headquarters, the salary of the president, CEO, and all the accountants at the central office, operating the website, which is a national expense, and advertising, which is a national expense. So we could further break those costs down into their components, and it's kind of interesting to see that, of the $15, about $4.15 is like the core ingredients and the packaging, and another $4.35 is the labor of the person who's there assembling the food, cashiers, people that are on hand, and the labor of maybe the manager that's there at the time it's being produced. Some of it is related to the rent, so the occupancy is the rent, and then other, I think, is things like the utility costs of the facility. It could be licensing and inspection fees that they're paying to the county. So it's really expensive to run a business. And when you look at a salad and you say, I could make that for $4, $5. It's true, but that's not just what you're paying for when you buy food at a restaurant. You're paying for somebody having cooked and assembled it for you. And then you're also paying for some place to sit, and you're paying for the fact that you knew about the restaurant through advertising. And so all of these things you're on the hook for, but in the case of Sweetgreen, they're trying to still look for a way to become profitable, and they're not there yet. I just thought this was a really interesting way to look at cost breakdown. But so if they're not making money selling salads for $15, hopefully the airlines are making a little bit of money by selling tickets on a plane ride. So this is a flight. It's about a 10-hour flight between New York and Rome. Actually, it looks like this is just one direction, 8 hours, 15 minutes. The other direction is about 10, because they're fighting the jet stream on the way home. $873. So I saw another graphic that was showing on a typical flight of 10 hours duration. This is showing how airlines make their money. So if you've got one flight with some first class passengers that are paying $5,000 and business class passengers that are paying $3,500, and then economy class paying $800, and then some baggage fees. So all of the revenue on average that you might get from a single 10-hour flight could be $250,000 for that flight. And so what this graphic shows is where that money goes, covering the cost of the fuel, covering the labor expenses of like the cabin crew and the pilots, which is a tiny fraction of it. The pilot and co-pilot, we think of pilots being really highly paid, and they are. In fact, there are some pilots who are flying international routes that make more than $500,000 a year flying. But as a fraction of the total revenue of the flight, it's just a tiny fraction of that $250,000 is going towards the cabin crew and pilot. Most of it seems to be fuel costs, and then the additional labor, which is like the people who are maintaining it, the gate agents, the people at the airline who are doing operational things like organizing the schedule, looking at the weather, and so on. A certain amount of it goes towards the plane itself, so the depreciation and leasing is the cost of the plane. But they do manage, on average, to get a little bit of revenue. There are a few airlines right now that are losing money, like Spirit is kind of notoriously in trouble at the moment. They're probably going to go bankrupt. But a lot of the big legacy carriers like United, American, Delta, they're more profitable now than they've ever been. They've kind of figured it out, and so it's just an interesting breakdown. There's broadly speaking, two ways to estimate costs. The bottom-up approach is where you're saying how much you would have to charge for an item to cover your costs and then also make a certain amount of profit that you'd like to achieve. So for instance, if you are Apple and you're deciding how much to charge for the iPhone, Apple might say that they want to allocate a certain amount of money towards the RAM, a certain amount towards the screen and the radio, the chip, packaging. Then they know that they've got the development costs and transportation costs, insurance, warranty costs, and then on top of it they want to earn 20% profit. So if they added up all of those things that they want to cover and keep, then that might tell them what required price they have to charge for the item that they're selling. And that is a reasonable way to do a cost estimation. And this bottom-up approach usually works well when competition is not a dominant factor. So that means when you're selling an item that is not a commodity. Because if you're selling an item that has a lot of substitutions, then you can't just decide what you want to charge for an item. There has to be a starting point in the top-down approach when there's lots of competition. You'd start with a target cost that you know will make it competitive. So like if you're selling an Android phone for $400, there's lots of Android phones that you could get for $400. And so if Motorola knows what LG is selling and they know what Samsung is selling, and then there's also Google selling their Pixel phones, like it's a saturated market, then they just pick a price that they know their competition is selling things for, and then they decide, based on we want this to be a $400 phone, how much we can afford to allocate towards these things like labor, materials, capital recovery of the equipment that's being used. And so the cost and the price of an item is kind of the starting point, and then you're working down. So top down indicates that you're starting with the selling price and figuring out how to allocate it towards different categories, whereas the bottom up approach, the price is the end of the calculations. Now, rather than either of these two extremes, ordinarily most companies are kind of toggling between the two. They're looking at the top-down approach, deciding how much they could afford to put into different categories, and then they're also considering it from the bottom up. So they're going back and forth iteratively before they decide how much they're going to charge for an item. And hopefully they've got market research that allows them to estimate what the demand would be, because that's also a big factor in your costs, is how many items you're going to be selling and the kind of bulk discounts you might get from suppliers of screens and RAM and even things like electricity. Okay, this is an important figure that you should be prepared to describe on the final exam. What it shows is that if you only spend 10 minutes putting together a cost estimation, it's probably not a very accurate estimate. You know, you may be only accurate to within 30% if you estimate something really quickly. So like this building, if you had 10 minutes to estimate how much they paid to build this building, you might just, first of all, add up the square footage and then try and get some data on the cost per square foot of building an academic building. That's maybe all you could do in 10 minutes. And if you did that, it would be okay, but it wouldn't be accurate as if you had said, well, I'm not just going to go by square foot for the building. I'm going to say, if you've got a day to do it, a full day, you'd maybe look at the individual systems in the building, and you'd say, all right, it's got carpet floors, it's got tile hallways, it's got 2 elevators. You know, you'd look at the quality of construction. You'd look at the types of materials that were used, and that additional time would allow you to be more accurate. Now you don't maybe be plus or minus 15%. if you had 3 whole weeks to develop an estimate, then you may actually call suppliers of each of the things and get bids. And so, again, you'd take more time, you get a more detailed estimate, and you'd have improved accuracy. But there's kind of a diminishing returns where you could spend more and more time putting the estimate together, and the estimate's not getting that much better with the additional time that you're spending. And so the question becomes, how much does it cost to generate a really detailed estimate, and is that necessary at every stage of development and design? Sometimes maybe the 10-minute estimate is good enough. Like if you know, for example, that you've got a $5 million grant from the state legislature, but the building is going to cost $50 million plus or minus $10 million, well, you already know you can't build the building. If you've only got $5 million available and the building could cost between $40 and $60 million, there's no reason to put 3 weeks into your cost estimate if it's so obvious that your available budget is way less than what the costs are likely to be. On the other hand, a really detailed estimate maybe would be justified if you're at the point of actually putting a bid out for construction and you want to know what kinds of bids are going to be reasonable. So it's important that you're able to describe this figure and what is the trend and what's the interpretation and what's the meaning of this curve. One should balance the need for accuracy with the cost of obtaining that accuracy. So you're taking a lot more time to get a more detailed estimate, and maybe you don't need all that extra accuracy in some cases. This figure is also important, and you need to be able to describe it for the final exam. And sadly, experience has told me that very few students actually manage to understand this figure. So if you can just focus for the next couple of minutes and absorb what this figure is telling you, I think it'll be time well spent, because what it's showing is that the horizontal axis is the passage of time. And if you're doing a project, there is the acquisition phase of a project, which is like before you get the item. So if this building is the project, the acquisition phase is like the planning and the construction. And then the operation phase is when you have the thing. So it's when you are maybe using a piece of machinery or you're operating the building and using it. What it's showing is that early in a project is when you've got the most potential for saving money. So this curve is going down because the longer you wait, decisions have been made, and it gets harder and harder to save money. So the easiest time to save money is early, like in the case of an academic building. If somebody's proposing that we build a 70,000 square foot building, but you're able to look at the needs and the demands and say, well, we actually only need a 40,000 square foot building. We don't need a 70,000 square foot building. Like, that's a huge dramatic effect on the cost of the building if you refine the needs and figure out that it could be smaller than people originally thought. You're going to save loads of money than if you get locked into the big building. From there, it's going to be harder and harder to economize because, yeah, you can put in cheaper carpet and you can use worse paint and maybe you can buy cheaper furniture, but still, it's a big building that's going to have to be heated and cooled and cleaned and built, and all of those expenses are kind of baked in once you've made the decision on how big the thing is going to be. So through these different phases, what this first curve is showing is just the potential for cost savings goes down over time. And if you look at the end of the operation phase, during the disposal phase, like when you're going to, part of the life cycle costs are getting rid of an item when it's used up. So disposing of a building or getting rid of old equipment. You can't save very much money. If you look at all of the costs that you've incurred through the entire life cycle, at the very end, you could use like maybe a slightly cheaper demolition company, but that's going to have just a tiny effect on the overall life cycle cost. So that's the first curve. The other ones are showing the cumulative life cycle cost. And so the first leading curve is the cumulative committed life cycle cost. And so that's about what money you've decided to spend. Not that you've actually spent it yet, but the decisions you've made and what you're locked into. So for example, during the needs assessment, if you decide on a 70,000 square foot building, you've already kind of committed yourself to certain costs. You maybe haven't spent the money yet, but you're committed once you've made the decision on how big the thing's going to be. So that is why the committed curve leads ahead of the actual cumulative life cycle cost curve. So what they're both showing is the steeper this line is when the rate of money spending is the highest. So if it's a machine, maybe your life cycle costs, you're spending the most money during the operation phase or during the construction phase. So this building, most of the cost of this building, the entire life cycle cost, which includes, the maintenance, the design costs, and the construction costs, most of the cost of this building occurred during its construction. And from here on out, there's just heating, cooling, cleaning, operational expenses, which are a smaller fraction of it. So the cost savings are easiest to obtain early on, and the longer you wait to make difficult decisions, the less money you're going to be able to save. Okay, so we've talked a little bit about the unit method. The unit method is just that you can find out how much you're going to spend by the number of units required and the cost per unit. So, for example, maybe operating a car costs 52 cents a mile. So you could find out what's the unit cost of traveling from here to Los Angeles by multiplying your cost per mile by the distance of a journey. If a highway is known to cost $6.2 million per mile, you just multiply the length of the highway by the cost per unit. And we could break different things into finer detail. So for example, building a highway, maybe at the broadest sense you could do it by per mile, but you might also say what's the cost for the area of asphalt? What's the cost of the volume of gravel? For the amount of compaction that's being done. So each one of the subcomponents could also be broken down into different units that we have a unit cost for each of the subcomponents as well. So I don't think we're going to be able to solve both sides of the in-class exercise for today, but I think you can do the first problem. So let me give you that. Okay, so this first problem is saying you're going to manufacture 1,500 sections of gas pipeline, and we know how much steel costs, what's the machinery cost, labor, and indirect costs. So try and put together a cost estimate to manufacture these 1,500 sections of a gas pipeline. It's just kind of like a standard algebra-based word problem here that's giving you a taste of the unit method. Okay, so if we use the unit method to find out how much this gas pipeline is going to cost, then it looks like the steel is $137,000. The machine and tooling, $180,000. The labor for the casting and treating is $165,000, $54,000 for the finishing and shipping, and then of course we have to cover the indirect costs of $30,000, and so the total cost here would be $566,700. So that's our first taste of cost estimation. We will continue with the second part of this in-class exercise on cost index when we get together in class on Friday. So hang on to the paper. We'll use it on Friday. Yeah.